There are 7 books on a shelf. If I want to keep 3 of the books next to each other, how many ways are there for me to arrange the bookshelf? We'll look at this in 2 different ways. The first one, let's think about blocking them together. So if we're going to block those 3 books together, that means we have 5 blocks. We have block 1, block 2, block 3, block 4, and the block that contains books 5, 6, and 7. That is a single block in this case. So there are 5 factorial permutations of the blocks, and 3 factorial permutations within block 5, 6, and 7. There are 3 factorial ways of arranging those 3 books within that block. So in total, we have 5 factorial times 3 factorial, which is 720 possible arrangements. The other approach would be to think about taking those out, and then we have 4 remaining books that we need to arrange. So we have 4 factorial permutations of single books, and 3 factorial permutations within block, and we would also have, or how many gaps are there here? There is 1, 2, 3, 4, 5 gaps, and we need to choose one of them. So we have 5 choose 1 possible gaps to place the block. So we have 4 factorial times 3 factorial times 5 choose 1, which is equal to 720. Prior to this question, let's think about what would happen if we wanted to have 2 blocks of books. We've still got this block of 3 books, but what about if we also had a block of 2 books that need to be stuck together? So we have one trilogy that needs to stay together and another pair of books in a series that need to stay together. Those could be next to each other, or they could not. So let's think about what we could do. In this case, we're now going to have the block of 3. I'm going to call this block 1, 2, 3. The block of 2, which is the block of books 4 and 5. And then I've got book 6 and book 7. So I have 4 things. So I have 4 factorial permutations of the blocks, and 3 factorial permutations within the trilogy, within block 1, 2, 3, and 2 factorial permutations within block 4, 5, the block of 2 things that need to go together. So that is, in total, we have 4 factorial times 3 factorial times 2 factorial, which is equal to 288. So 288 ways to approach that. Have a think about how you might approach that using the other method by choosing the gaps. I think it's a little bit more tricky with this particular example, and this one is more direct, but have a think about how you might do it.